This meeting is being recorded.
Hello, welcome back to the second part of our online vessel performance forum, connecting shipping industry goals with digital technology. In this session, we'll cover development of decision support tools and the players in vessel performance with two great speakers. I'm introducing you to them. Firstly, Mike Servos, Energy and Environmental Manager at Minerva Marine, and secondly, Giannis Papageorgiou, Vessel Performance Expert. Carl Jeffrey from Digital Ship is moderating, and he will start with a short introduction. Let's go, Carl.
Okay, so the theme is filling the gap between gathering data and making decisions in vessel performance. And the reason we picked the theme is that a lot of the vessel performance discussions we've had so far have been about the challenges of getting data and analysing it, but there's a lot of further steps we need to take from when we get the data about ship performance on our screens to the point where the relevant people are making the right decisions, and there's lots of different people involved. So we've got two speakers in this session. We have oops, I have the wrong introduction. So we've got two talks from Minerva Marine, and then we've got a consultant who's working with big container shipping line. So the first talk is going to be very technical, and the second talk is more people and role orientated. So first of all, Mike Servos, Energy and Environmental Manager with Minerva Marine, is going to give us a review of the regulations and what companies can do to get better scores and pay small amounts of money. He's going to show some estimates of the financial impact of the EU emission trading scheme, which is the first time I've seen these numbers. And he's also going to throw cold water on the idea that cutting speed is always the easiest way to reduce emissions, because he's calculating that a 5% improvement in your CII score might need a 8% reduction in speed, which may not be commercially viable. And he's also going to explain why Minerva decided to develop their own systems rather than buy them. Mike leads the Energy and Environmental Department of Minerva Marine, Minerva Dry and Minerva Gas, which has about 75 vessels. He's responsible for development, maintenance and implementation of the company's energy and environmental management system. So Minerva Marine is a tanker, bulk carrier and LNG operator. And second, we're going to go to Copenhagen, and we're going to hear from Giannis Papageorgiou, who's a vessel performance expert and senior consultant. And he's going to look at the different roles involved in vessel performance and how they relate and map together in the organization. So that might include chartering departments, network planners and ship managers, as well as the crew and the performance managers. But we've got to get the right information to the right people if we're going to make all this work. And the data analyst is going to have a more and more central role in the chain, he thinks. So he's saying improving the performance of ships is a combination of scientific methods like data analysis and doing the right everyday tasks in the office of the shipping company. I think culture is one of the hardest things. So Giannis has analysed performance of hundreds of vessels, from heavy lift carriers to the largest container ships, looking at port time optimization, tank tests, and all the detailed aspects of the vessel and its operation. So we're going to have two talks, each 15 to 20 minutes each. You can put questions anytime in the Q&A box. We're going to take the questions at the end, but the speakers might be able to answer questions by typing while the other sessions are going on. And there should be a lot of time for questions at the end, but I'd like to invite Mike to give the first talk. Thank you.
Thank you, Carl. Please allow me to share my screen. So good afternoon. First of all, I would like to thank VPO for the invitation and the opportunity to share my thoughts with you. As you are well aware, the journey to decarbonization has started some years ago. IMO has set a target for zero emission shipping within a century, while EU, being more ambitious, has set a specific deadline for 2050. It is unavoidable that shipping adapts to EU expectations. This slide depicts milestones toward decarbonization and expected contribution of various areas in achieving these deadlines. Amongst others, in my presentation, I will focus on the short-term measures that will have to be undertaken by the shipping companies to meet those deadlines, and I will present examples of the financial impact. Now, let's see what lies ahead of us, starting from the EU initiatives, which are expected to have an immediate financial impact. As you are aware, the European emission trading scheme will expand as to include the maritime sector starting from 2023 with a phasing period ending in 2026. The proposed amendments enforce the pollutants pay principle and underlines the need for a contractual clause making sure that ETS costs would fall on the entity that is ultimately responsible for the decision affecting the CO2 emissions of the ship. That includes choice of fuel, route, speed, and choice of cargo. That means that charterer, in many cases, will be held legally responsible for paying the carbon costs. Under the current proposal, the shipping companies would have to surrender 20% of verified emissions for 2023, 45% for 24, 70% for 25, and 100% for 26. But there are proposals submitted calling for an acceleration of the phasing period, recommending that the shipping companies should surrender 33 of the verified emissions for 23, 66% for 24, and 100% for 25 and each year thereafter. Also, the inclusion of all emissions, and not only the 50% of this, has been proposed. The graph at the right bottom side of the slide depicts an estimation of the involved costs based on current proposal, which is the good scenario, and the proposals currently under discussion, which is the worst case scenario, for a typical Aframax round trip from US to the Netherlands. As you can see, in worst case scenario, the additional cost could reach 380,000 euros after 2026. But actually, this is not the worst case scenario, since subject costs were calculated based on a price of 90 euros per metric tons of CO2 emitted. The worst case scenario involves CO2 prices exceeding 100 euro per metric ton of CO2 emitted. Further to the ETS, and in order to stimulate the uptake of the sustainable maritime fuels and zero-emission technologies, EU introduced the Fuel EU Maritime, who sets a maximum limit on the greenhouse gas intensity of energy used on board while operating within the European Economic Area. The greenhouse gas intensity means the amount of CO2, methane, and nitrous oxide emissions per megajoule of energy used on a well-to-wake basis. The well-to-wake method includes not only emissions from combustion of fuel on board the ship, but also upstream emissions from production, transport, and distribution of fuels. The shipping companies will have to improve the greenhouse gas intensity of their vessels at the levels shown at the slide. Companies that are not complying with the rules will have to pay penalties by 1st of May of the following year. For the same round trip, from US to Netherlands, the compliance penalty shall be 72,000 euros. Furthermore, the heavy oil used in the maritime industry will no longer be fully exempted from the energy taxation for voyages in the European Union. The revised Energy Taxation Directive proposes a maximum tax on heavy fuel oil starting at 0.9 euro per gigajoule in 23. That translates into a cap of 38 euros per metric ton of fuel. The ETD introduces a risk that shipping companies will no longer bunker fuels inside the EU. On the other hand, IMO, being more conservative on its approach, adopted a series of short-term measures targeting to greenhouse gas reduction. EEXI, the Energy Efficiency Existing Ship Index, is one of these measures. The EEXI is a technical design-related measure which practically introduces a speed limit and is expected to impose barriers in trading for a significant number of ships. Ships have to approve the attained EEXI value once in a lifetime, latest by the first renewal of International Air Pollution Prevention certificate after the 1st January of 23. The majority of the existing fleet will experience a reduction in propulsion power, either by imposing engine power limitation or by using shaft power limitation. The draft EEXI implementation guidelines were just released yesterday. This is a document from Ajax. The latter, in combination with the short deadlines, is expected to create a bottleneck in deliverables both from providers as well as from classification societies when it comes to EEXI technical file approvals. Last but not least is the IMO CII Carbon Intensity Index and the rating scheme that comes with it. The yearly CII shall be calculated based on reported IMO DCS data, and the ship shall be given a rating from A to E. For ships that achieve a D rating for 3 consecutive years or an E rating in a single year, a corrective action plan will have to be developed as part of the CMP and approved. There are correction factors that currently are being under discussion, and these are correction factors for ice-class vessels, shuttle tankers, ship-to-ship operations, navigation in ice, refrigerated containers, and cargo handling of tankers. This is a work in progress, and we still don't know if these are finally going to be adopted. A number of commercial and legal issues are expected to arise before and after the CII regulation come into force. An important commercial question is who will bear the cost and responsibility of complying with CII between owner and charterer of vessels under long-term period charters extending beyond 1st of January 23. More implications are expected to arise since owners of time charter vessels must comply with charterers' employment orders relevant to CII. However, these orders could affect the vessel CII rating, which owners must still comply with. Also, decisions by owners to slow steam, reduce cargo carrying capacity, or deviate to maintain their CII rating could put them in breach of charter party and make them potentially liable in damages. Furthermore, dispute over spot fixtures could arise if owners take operational measures to maintain a CII rating, which can result, for example, delays a voyage. Again, this could put them at risk of breaching their obligations to proceed with due or utmost dispatch, and how this will settle remains to be seen. In order to get an idea on how CII will impact operational vessel, I have prepared a case study. The graph depicts hypothetical rating of a Cape vessel somewhere in 2024. Vessel CII is assumed to be 2.7, which means that the vessel has been rated as D. The error bars that you see that depict the 5% boundaries. Assuming that you are the manager of the vessel and you wish to improve its rating from D to C. Speed reduction might be a solution, but in order to improve your CII by 5%, you will have to reduce the speed by 4%. This is what our study shows. As such, for an initial speed of 12 knots, that translates into an almost 0.5 knot, which may not be commercially viable. The speed reduction of 0.5 knots corresponds to half a voyage less per year if the vessel is engaged in voyages between China and Australia. At the same time, let's see the impact of technical efficiency of various consumers of a tanker vessel and specifically on an Aframax with steam cargo pumps engaged in ocean crossing vessels. The table shows distribution of consumption per mode and area and their potential impact if not properly attended. As we can see from the table, the potential fuel increase within a year can reach up to a moderate 24% if not properly attended. Interesting enough is the fact that if a vessel was in the same position with the Cape of the previous slide and had to improve its CII by 5%, instead of reducing speed, could invest in improving the efficiency of its port operations, and in specific, the discharging operations, which accounts for 5.4%. Provided, always, that these consumptions will not be exempted from CII calculations, which is still, the discussion is still in progress as mentioned before. It goes without saying that the benefits of investing in improving the hull and propeller efficiency of a vessel could be even higher. What I want to stress out is that the significance of technical efficiency increases while speed reduces. As speed goes down, technical efficiency will be more and more important. Now, let's go to decision making. Having in mind the complexity of the decisions that needs to be taken, there is an imperative need for the appropriate decision-making tools. Some of these tools might be off-the-shelf solutions, while others might be developed by the shipping companies, either in-house or outsourced. The expertise available and size of the fleet are decisive factors on the path to be followed. First of all, you need to identify the problem and the stakeholders. The next step involves establishment of a reliable data collection system and subsequently the determination of performance baselines. Only then you can proceed to the next steps that include the development of tools that will allow performance, emission, and financial impact prediction. The tools must include sensitivity analysis on the effect of key parameters. The final step includes an evaluation on whether or not the decision you have taken has resolved the need you identified in step 1. The tricky part in this process, it is the belief of a significant number of operators that steps 3 and 4 are already met. I would like to stress out that the IMO DCS data alone are not as sufficient to establish the performance baseline required in order to proceed to have an effective decision-making system. In Minerva, we have decided to start from scratch and invest into knowing our vessels. We have chosen a mixed approach of outsourcing and in-house development, while whenever needed, we are reaching to the industry for expertise that we do not possess. This approach allows us to have the full ownership of the platform and customize it to our business needs, giving us a competitive advantage. Furthermore, by developing our own platform, we have managed to achieve a significant economy of scale. Of course, it is a slow process, but it's worth the effort. The foundation of our platform is the integration of more than one data sources. We collect high-frequency data, and we integrate this with the noon reports, as well as from data that we collect from weather providers. In this way, we ensure availability of data and that these are always validated. Some examples of type of analysis that we are able to do to perform in-house are depicted in the following slides. We have invested a lot in hull and propeller efficiency. Previously, we have identified hull and propeller as the most significant technical aspect in improving the performance of a tanker, not only for a tanker, but only for a bulk carrier or even an LNG. So it made sense to start from there. With the use of data analytics in combination with improving our dry dock strategy and implementing an enhanced program of underwater maintenance of our ship, hull and propellers, we have managed to achieve a 6% reduction of the daily fuel penalty attributed to fouling over the last 3 years. Furthermore, we have invested in improving the efficiency of our discharge operations. As such, we have expanded the scope of collection of high-frequency data to ships, pumps, and steam system. By doing so, we have managed to improve the efficiency of our discharge operations by 30% over the last 2 years. It must be noted that crew members on board the online vessels tend to adapt faster to changes and show higher level of awareness, thus contributing significantly to the improvement of the efficiency of the vessel. I would like to say that there are more to be done to increase the efficiency of a vessel, but in this presentation I focus on some operational measures where a shipping company has the level of influence required as to see immediate results. I will leave it to Giannis to elaborate on the stakeholders and the complexities involved in further improving the efficiency of the vessel. Thank you.
Well, thank you very much. So it's an amazing overview of a whole range of different things. So we'll go to Copenhagen now. So hear from Giannis Papageorgiou, who's a vessel performance consultant. Cheers.
Oh. Yeah, thank you very much, Mike and Carl. Very interesting, Mike. You gave a quick overview of many of the things that are needed to be in consideration, are mandatory for for all the shipping companies, and everybody is working on reinventing the wheel. I have to say, many times when we work independently, many times we are all working in the same problems, and yeah, that is I would like to touch into this presentation. So vessel performance and players across the chain. So along the operation of the shipping and all the supply chain, if you see it as broader, the vision of that we are here. Last years I've mostly worked with containers, but then it's across the industry of the shipping. We are supplying the goods for the world, what is needed, and the objective is to reduce and decarbonize in the end with the regulations that they set, as you saw, because we get all the warnings from the science for maybe a century now or centuries now that this is going very high, the global increase in temperature, and we don't know where it's going to end and where is the tipping point and what can we do to reduce at least the rate of increase. So we have plans to decrease, but what are the motivations of people because on contributing on all of these? I think there is a collective feel of obligation, social responsibility as well, when you feel for all the planet, for the ecosystem that you own, for that it's also part of the that there needs to be in the agenda, and that you also need to contribute with your good efforts to this hard objective, which is to decarbonize and to reduce, in order to have a positive contribution of your life, like as well, right? On this planet as you crossed it. I would talk about data that we do that. I think many presentations talk about data. I strongly believe about auto-logging because yeah, we pass to the Internet of Things, the connected, the vision of the connected vessels, and we have the non-intervention from the human creates trust in the information they carry, more that we have the need as we are far away of this, and the quantity of them allows scientific methods, statistical significance, for example, on the results. But we see like problems like it's also typically discussed that it takes much more time if you see as an effort to obtain a good data set and then to analyze and give the results. So it's a lot of efforts there. And the results that we need to pass is a KPIs along, some of them that you shown, some increase, some decrease, but they are need to be very, very short to pass the technical methods of reduction of emissions, consumptions, or yeah, the effects or increase in profits as well when it's companies are operating, and so how we reduce the costs. I would place like to show this as an example. It's not very well shown here, but we can see here, like we can see that like the data analyst in the center, if you imagine like have that he's collecting data and information among many people, like from the management to the IT to the technical department in the shipping companies, in the operations, the network planning, chartering department. These are on the left, like the internal of a big company, some of the key departments that data are needed and information needs to flow there. And the charter department gives the gate to talk to others as well, externals, or then you could say the crews as well. There is a lot of communication and need from data, or to the small, like the vessel performance analyst needs to have talks, among others, with the innovators, vendors like startups, or that they provide in, like, what the solution are coming from others, from externals. They need to talk to the academia, to the class. So it is, I'm claiming it's becoming a more and more central role in the industry when all of this information is gathered there. So yeah, that's what I say. And we need to talk to all, except of analyzing the data. You need to have very good, for example, in this case, communicational skills. So in order to be able to pass a message and the same objectives to so many different people from different backgrounds in other edges of the world. Then I would say I would go a little bit through some of the other players. I would say, like, people on the office, the technical department, for example, they have access to information. We need to understand more the reality on board. They are, though, many times, like, I would they are doing their best, like, for the like the difficult subjects, let's say, to change fuels. How can we go to biofuels, or and what steps are needed there? But they need not only technical information from what the report is saying about the quality of the fuel or an engine, how it will react, but to understand the processes on board, and yeah, many things that are not clear from a computer screen in front. The crew, we have some of the key players, I mean, that they play a role in the performance. The captain, of course, with his choices on speeds and routing. The chief engineers with the operation of the engines. The electrician, that if he has done, of course, a good work to connect all the sensors needed. The reporting of the second officer, maybe the manual reporting many times that it still maybe covers a bigger, some data that are not, there are no sensors. What I see there, it's like more a need that they need to receive feedback and need to get a broader understanding of how the office is taking decision, is working, how their good efforts are on board are appreciated in the office, because they don't realize many times on how the data collected are used, or what is the impact of running an engine when it's not needed, or arriving earlier on time. So many safety margins, for many cases, they are for very good reasons there, but for many cases there is as well, we are balancing here between actions that are having a big global warming potential, especially when we talk about containers. For example, the Maersk had announced that according to their estimations, 1 out of 1,000 tons in the atmosphere of the Earth of CO2, it's coming from this fleet. CMA CGM, it's not much less. So with the amount, so we are talking about 1,000, like really big numbers if you have into your mind the size of the Earth. So the actions among the crew, among everybody here that we are mentioning, they really contribute, even if it's a 3% of global emissions on the, if you see the IMO numbers, but for this whole industry. But yeah, some companies have, of course, and the decisions, they're bigger role on this. Then I would talk a lot as well about the developer. there are many different tribes. You could call the back end, the front end. There are different. They are the designers, the architects, the solutions. They are maybe from fixing nice bugs, like in that they appear on the analyzing of the data, or building, like we have to see building of a, it's not the building of a ship, but the building of a virtual of a product that it's actually big part of a company if it's the tool that it is going to analyze all the fleet, hundreds of vessels. So they bear as well a lot of responsibility on if a bug doesn't work and we cannot really see results for months, or if a clever design will allow speed on results and insights to be given easily and to everybody. Data science is somebody that it's more recent coming into the game. He could be a very valuable contributor. The data, though, of course, it needs to be like have a strong background, I believe, on physics, because we cannot just see from the numbers and understand, for example, the waves. So there are here, when we analyze data sets from various of sources, from meteorology to engines inside the ship, we need to understand very well what is happening and how these things are connected. This is not only the data scientists, I believe in the end, it's everybody that needs to give a better effort in understanding. But the data scientist has a role, of course, when he sees the contributions of the data and give some results for analysis. There is the AI. What can it do? I mean, there are many discussions. How can it help? If we can say if the AI is another player in say artificial intelligence, and when we see like from the news, like of science in general, like that's it can predict the shape of the universe. I mean, if it can find something like that, then definitely can do something regarding ships data, and that it could be, yeah, for helping us in problems that we don't have so good laboratory tests. For like model tests, or for example, for predictive maintenance, we could use it. So the robot itself, if it is a player, the code, we can try to analyze what's happening by itself, where it's powerful, doing a lot of computation, but needs a lot of training and really needs to work in a good data set, like with a lot of cleaning. As we say, like it was very big effort to collect a good data set, to train it. The manager as another key player, of course, they needs very, like many times he wants to see results, of course, and then and improvements over time. But many times it needs to see the complexity of the things, of the analysis of the different data sources, of the combination of factors for the right decision making. I believe the manager, the ship owner, they of course affect in the very big role on how the strategies are, and what the end results are, with what vessels were chosen, what projects were chosen, when to be implemented, etc. We could say about a network planner or the chartering department. For example, if you see the picture of the positions of the AIS, you see the global shipping lanes, and Yeah, and you are into this game of choosing your vessels, not optimizing only a single ship, like checking a single performance and marking it A or B, but then if I have to operate 500 ships, where do I place them, in what speeds, and how, like, where are the most efficient vessels going? How is that fitting the needs of the market? How can it reflect in the market change if the market changes? So it's a choice that, of course, needs data, and the data from a single ship are collected to a fleet perspective and analyzed in things, for example, that you can have a network and you are not in shipping like the tanker and the bulk industry. But yeah, it's one of the points that a lot of optimization can happen on choosing the right ones. Or from some other play like that are typically forgotten, like the spares, that the equipment is many times breaking. And even if you are if you are the supply chain, if you are the company, like big container shipping company providing all the products to the world, maybe you don't have very fast things that are that you need in order to analyze or so this, like even the work of a person that's arranging the deliverables ownership, it's very much affecting, because if we don't organize it right, then we will don't see results for some months until it's next available or to deliver to a vessel, and then we lost some insights with what happened there. The port authorities, as for example, yeah, a lot of times vessels arrive and wait unnecessary to speed up to arrive on time, but then it's congestions, and as you said as well before, that the big savings are first of all achieved by reducing the ship's speed because of the propeller's law to the third power of the speed in the third power. It's representing the emissions and the consumptions, at least on a container. It's a discussion if it's in what speeds, then we maybe even talk for higher exponents. There is an innovator like a startup or another external company. It's of course playing a role, like how can we improve? And I would say, like, for these companies that they want to come like and say we have a solution and that can bring all of these changes, like really I think one as well, Aristo mentioned it in his words that he was that we need to bring up as well the value of what is new, and because there is a whole market, like, and the offering solutions. So what is the difference? And maybe many stakeholders among the web, like that you saw before, of a department should buy it, should be persuaded that it's a new thing, that it can. So it's not only, of course, it needs technical justification for a solution, but it needs to fit to many stakeholders to see the value there from their different backgrounds. I would say the academia, it's not something to be forgotten into this game, and we have as well a lot of needs if we need to analyze difficult problems, to cooperate closely. If we want to have research and development departments that they they are able to give better results in the future, a professor can, of course, is focused amongst the knowledge and the teaching and the explanations giving, let's say, for wave resistance or all the subjects that are on on the state of art of the industry. He typically has a lot of manpower students as well, but or possible PhDs. They lack cooperation from the industry on sharing full-scale data and funding many times, unfortunately. When a lot of showing us where the technology can go, of course, comes many times from the academia. So this was in short presentation, like the full structure. I would say who is affecting the performance. I would a little bit more like who is like, imagine this web, all of these players are into a net, and who's the responsible in the end when we see. So I would say Hannah Arendt, she had some thoughts on how did we end up in Nazism in the end, who was responsible, how that was possible that people reached up there. And there was a lot of about that she was talking about that say, you know, it's not my fault, I just obey orders, and that they told me to, or that's how the things are. So this being neglected about deny the responsibility of the person, it ends up in very bad situations, and we can end up in global warming, as the IPCC is underlining. So if you put it in Russia's charts, it's who is responsible. This famous among the companies, so to spread the responsibility. So we would say all we are in a well, but of course fewer are more accountable for the impacts. The target is given, the science is publishing every month, like what are the adaptation, the science basis, and of course at the end we would like to say, yeah, the collaboration needed, that it's there. If you're gonna decarbonize in the end, it is a major technological revolution that's needed, and it's a company alone, even if it's big, it's cannot do that. So it is the step we need. I mean, with data, with collaborations across all the players to achieve that. Yeah, I would say, Carl. Yeah.
Oh, thank you. Is that at the end? Yeah.
Yeah.
Oh, thank you very much. Yeah, that's fascinating. So I think we've got two talks. I was thinking, the first talk from Mike was going more into the rules and the money side of it, building on the data, and then Giannis was getting more into the roles part of it, building on the data. So the data is still really hard part, but these are all things that people just barely even start to think about. So we're going into the Q&A part of the session. We don't have any questions in the Q&A box, but I've got a few of my own. Maybe I'll start with Mike, if you want to turn your camera on. So I think Giannis had a graph right at the beginning that it takes about 4 times more time to obtain data than he spends analyzing it. I don't know if you obviously spend a lot of time analyzing your data. I don't know, does it get any easier over time when you to gather the data, or is it always difficult, do you think?
It is not an easy process. I guess if I interpreted correctly, what Giannis was presenting is the effort that you need to cleanse your data and come down to the quality that you need those to be as to make the analysis. The analysis part is the easy part, I would say. I would agree with Giannis. The difficult part is to identify outliers or any other hidden malfunction within your data. Otherwise, I would agree with Giannis. The trickiest part is to get the right data set.
Oh, okay, because I mean, we had the theme of this was what you do with the data, get to the right people, but I guess getting the right data is still the hard part. I guess that's not going away, isn't it? Yeah.
It's not an easy part because we still have to remember that not many of the sensors that there are on board currently were designed initially for the purpose of collecting the data from this, for example, draft sensors, speed logs, and stuff. And that makes our life not so easy.
Yeah. Good point. That they were not designed for this, and I think the modern ones need all to get to this point when telecommunications become easier over time, and we have internet on board everywhere. And yeah, so I would say like it is not only the cleaning, but if you imagine it as well, how much is the effort to get to connect it, like to find it, like even if it's not designed, like where to connect conversions, the shipments, how much time is there on this. It's much bigger than when having a good data set and then doing a lot of analysis on it. So
Well, we've got a question from Bob Ball from BP. I think he's an electrical superintendent. He's saying if we simply slow vessels down, then we're going to need more vessels, and we keep the emissions as they are. I guess the answer is something about the speed curve. I'm sure Bob knows about that as much as you do. I know it doesn't always apply. Do you want to? I don't know who would like to. Maybe Mike first. Do you want to?
Yeah, that's it is something that is being discussed as we go down in speed. Then we will need more vessels to carry the same cargo. I don't know how this is going to transform in the future, but since the consumption and subsequently the emissions are in cubic law compared to speed, unavoidably emissions will go down as speeds go down. I don't know if costs will go down, but emissions and subsequently, yes, the emissions will go down.
It's interesting. Oh, God, yeah,
it is. I agree. Like because we spread, like it's not linear, the combination. So it's like a curve, a strong curve there. So that it is then going as Mike is describing it. So, and also like I have to add that it's the economy of the scale. So when we see a 3,000 TEU container ship and now, for example, a 23,000 TEU, the efficiency of each one of these, it's very big. So I know, for example, some local Copenhagen effort sales ship trying to be ecologic to carry cargo with sails, but because of the size that it's very small and it's kind transfer maybe the amount that one container is carrying, even though it's just sailing with sails and it's just maneuvering out of the port and is using some gas for the kitchen. If you take it divide it by the how much is the per nautical mile per kilo that you carried, the bigger container ship that looks massive for pollution was more environmental friendly. I don't say that it cannot be done. No, a lot of savings are needed in the big containers as well, but the amount of ships, if you had thousands of sail ships that they just maneuver out of the cargo, then they add up a lot. Of the maneuver out of the port, they.
Well, there's a question here from Giannis from somebody says, just gives his name is Stratis. What's the main problem for collecting data on board? Is it the lack of equipment, the lack of interest from shipping companies, or something else? How can we overcome it? I guess it's people like you that are working very hard, you and Giannis, to get better data collection systems on board is how to overcome it. Is that I guess there's not much more to...
What's the problem with the data that to come? I think it's I think it is a very big problem that the shipping industry has is the non-standardization that it has. We do not have every vendor. It's having its own formats, its own outputs on the signals and its specification. I mean, back in Force Technology, my manager used to say that for example, when you imagine connecting a wire like in your cable, the HDMI to your laptop. It's a very standard thing, and all the makers of screens then use that. Then we need, if it was simply standardized, all of these Modbus connections in the end in the engine room that we need to transform data, then something's not working, and yeah, it could be avoided, right? Simply by efforts that maybe the big companies should initiate to motivate the industry to standardize.
Yeah, Mike, do you have any ideas about how to make it much easier to collect data on board? I guess the airlines have solved the problem, haven't they?
My point of view is as equally important is the suitability and accuracy of the measuring equipment on board. If you make the proper selection from the start, then you have solved a lot of problems.
Proper selection of sensors, is that?
The appropriate sensors and the measuring equipment on board. Their selection is, if I have to put a percentage there, is 50% of the work to be done.
Oh, okay, that's very interesting.
There are many products claiming that they can deliver the required accuracy, but at the end of the day, it's not. Going back to the previous, it's about collecting the data and the effort that you need to ensure that the data that you have are properly, are accurate and validated. So my effort will go to the appropriate selection of tools and measuring equipment.
Okay, so there's two questions here. So Nicholas Kuvaras is asking, is there any off-the-shelf data collection and analysis system mature enough that solved all the data quality issues? I imagine every ship is different, so the answer is no. And Harriet Anisette Johnson is asking, she says she works in behavioral science with airline pilots. Do you think there's a need to increase engagement of the crew? I guess the answer is yes, but I don't know if either of those, which of you would like to share any thoughts on, do you think?
I would like to take the last one.
Okay. Yeah.
I would like to share our experience with crew members that are on board vessels that they are online, and they tend to adapt much faster to the instructions that we give them. And as such, we experience significant improvement when it comes to operational measures that we need to implement on board these vessels. Either it is from discharging, either from auxiliary loads management. Somehow they adapt much faster to these changes. I think that they know, they can understand the psychology behind it is that they know that their performance is somehow being monitored and evaluated. But as mentioned in previous presentations, we never sacrifice the safety of the vessel in order to increase its efficiency. So whenever needed, the second generator will be running. We don't give such instructions of, we don't jeopardize the safety of the vessel just to save a small amount of fuel or whatever.
Yeah, yes, I agree. And it's an important point, of course, the behavior and the psychology of the people on board. And with the collection systems, the data, I remember in a captain seminar training, when they were trainings of captains for container ships, you could leave some papers on the class, on the auditorium, and then they could write without seeing, like who said that point, or some comments. Then some of the comments written said that we feel monitored and we feel watched, so we feel a big brother. But it's not the point to monitor people. The point is to reduce emissions, for a warming planet, and which fits well with the company's profits because it's reducing its costs. So it's all good. It's not to say who is behaving bad, but what actions, and to give, let's say, if they feel for many cases unsafe, to do a choice that it is less efficient to show like how other people through the data solve that. Not to monitor who is good and who's bad, but to share information and knowledge among in the end as well.
Yeah, just come up to Nicholas's question. So I've looked him up on LinkedIn. He's Group Technical Manager Decarbonisation at Bernard Shorter Ship Management Greece. So he's asking, do you want to recommend an off-the-shelf data collection analysis system? Do you have any thoughts for Nicholas, either of you?
I
think they already have their own systems by now at BSM, but
they have their own. Yeah. Hi, Nick.
Hi, Nick. Yeah.
Okay. Please take it.
I think there are many really in the Serv. I mean, there are some that are much in front, that they have given it years of development, and somebody should have that in mind, that when some company is starting, it has years up front. Some have started working on this before 2010 or from 2005, or then many have gathered lowly, or many just muscle up with big investments and hire 100 people in a month, but then they need to communicate between them to build up their codes and yeah, I think it's not easy to say A/B, but it's a good choice always to take many and compare. And who is giving, who is fitting your needs. That's through other systems, you see different things sometimes, or even on the same ship, it looks different. Then what's going wrong? Who's right? What's the reality? Like, what's objective reality? Like, where is a mistake if there is? I mean, yeah, there is not one source of truth. In the end, maybe there is, but so.
Yeah.
Trust them, a more scientific approach, I would say. Get the hard questions to be the criteria.
Well, we just got about 2 minutes left. I don't know, Mike, you'd like to try Kostas Saritis' question. He's from Danilek Marine, which makes VDR and ECDIS systems, but he's asking, if a ship starts from scratch, how long does it take to put this in place? But it seems like this vessel performance project is more and more complicated every month, so I don't think, Imagine you'd ever finish
It's
it.
a slow process. It's a slow process.
Yeah.
Sure. If you don't take something that is off the shelf, well, I would like to get back to the previous question. Actually, I must say that there are beautiful solutions out there, off-the-shelf solutions, but even the best would fail if they don't have the support needed from inside the company. It's not about using just a software. You need the support from the users. And this is a very critical step that someone has to go through in order to get the results that he wants to obtain. Now, going back to the last question, yes, of course, it's a slow process. And now I don't know if we have the time to go through the cons and pros of in-house development and stuff, but for sure, I would say that for the size of our company, that gave us a great economy of scale and very big flexibility on the path that we need to follow in order to support the business needs of the company.
Well, and do either of you have a very quick answer to this last question? So Stavros Naotis, I think, is from American Bureau of Shipping, Senior Principal Engineer, Global Gas Solutions. Do you think class societies can get involved in verifying accuracy of data? Is this something you'd like to see? Maybe just a very quick answer. I guess they'd probably charge a lot of money for it, wouldn't they?
Yeah, but I mean, if you can set up a rule that we know an HDMI output on all sensor, like, or something, then maybe it would help the speed of installations, and we get connected in a week, like tack, get the cable. Maybe we don't even need cables, I don't know, but it's, probably sometimes regulations help, like to standardize the market.
Well, any last words, Mike? You want to?
Yeah, about the last question. Actually, the class should have been doing that. Because when we're talking about signals and data, it's not only about performance. The sense of performance that we are discussing right now, it's a matter of safety. You have alarms, you have the alarm monitoring system of the vessel. So yes, all this equipment used on board should be checked, verified, type approved by class, not always given the nature of its use. Of course, I don't think that we need the classification. But if you're going to the AMS, to the alarm monitoring system to collect data, my experience shows that they're not always accurate because of the, as Giannis elaborated previously, this issue of standardization and integration. But no, going out of the performance monitoring concept, yes, class should go deep in the signal processing and validation issue.
Well, thank you very much. I think that's the end of the webinar. I think you've both been great at showing whole new areas of this vessel performance subject we haven't seen before. And thanks very much for that. I shall pass back to Vida. Cheers.
Thank you so much.
Well,
thank you very much, Giannis and Mike, for sharing your thoughts. Also, I'm thankful for all the attendees who tuned in. We had about 500 people registered and half of them connected live through our 2 sessions today. I invite you to keep an eye on our webinar pipeline. Also, join us to our annual conferences in Athens and Copenhagen in May, if you can, of course. So VPO is signing off. Take care. Bye.
bye-bye.
Thank you. Bye.